Hey everyone, good morning, good evening, good afternoon, depending on what time zone you're on. Welcome to our latest webcast. It's good to see so many people here, some old faces on I haven't seen in a while. This is really great. Uh, and some new folks, so welcome. Let me go over a couple of logistics before I get started. The first one is this session is being recorded, and we'll have a recording up on our website and on YouTube in about 2 or 3 days, definitely by Monday. The second one is the way to ask questions, and I'd like everyone to stay on mute because if you're not on mute, sometimes background noise comes in and it messes up things. So I'm going to try and keep everyone on mute, but if I miss it, please put yourself on mute. But the way to ask questions is in the top right, you should see a chat button. And if you click that button, you can ask a question through chat. You can say hello or anything you'd like. I may not get to them in the middle of the talk just because when I have the slides on full screen, I don't see the chat button. But I'll take all the questions I can afterwards, after we're done. So with that, let me dive in and say welcome to the next in our series of webcasts on Informix best practices. And I'm going full screen, so I can't see the chat button when it's full screen like this. So this is, I want to talk about using the Sysmaster to do Informix health check. And we'll talk a little bit about what it is first and then how to use it to monitor your server. And this is sort of based on the last 4 or 5 years of doing health checks with clients around the world. I'm going to show you how we do one. Most of what I'm going to cover is going to be in scripts that we'll provide to you. Now, I've done a whole bunch of presentations on the Sysmaster database going all the way back to 1997. And some of them are on our YouTube site where you can see them. And some of them are not. Some of the slides are on the IIUG website. So let's just dive right in and ask the question, what is a Sysmaster database? I like to say it's a database that peeks into the shared memory structures of a server. So when you have your Informix server up and running, you have a resident segment of memory, a virtual segment of memory, and a message segment. In the resident segment are a series of control structures. And these control structures are where the server keeps track of everything. And remember, this shared memory is shared by all the on inits. So this is how the on inits coordinate with each other. The Sysmaster is a view or a peek into those control structures. And it's there, much like OnStat is, so you can look at and see what's going on and maybe troubleshoot and determine if there are problems or if everything's running fine. Now, it contains a bunch of server information. It contains information about all your DB spaces and chunks. As an example, when you start up Informix, it loads all the chunk information into these control structures. And it's there for you to query, or if you run an OnStat -D, you're going to be looking at the same information. Table and database information is there. User session is there, and current running SQL is there. Now, when you query the Sysmaster database, you're reading shared memory. You're not reading real database tables. But there are a lot of views that have been created to make it easier to understand these tables. And those views may take disk space. My classic example is syslocks is a six table join on sys6 underlying base things. And if you have 1 million locks, that can create a very big temp table and so can appear to be very slow to access syslocks. A lot of the temp tables are created with unbuffered logging, so that will also impact performance. Overall, though, the performance is just like running OnStat. It's reading directly from shared memory. There are a few tables, syslocks being one of them, where you may hit performance problems. Now, it's not a regular database. They're not real tables, except for a few exceptions. You can't update the Sysmaster database. If you could, and they've gotten pretty good about preventing you from doing it, but in the old days you could, you would end up corrupting your server. Because then what's in memory and what the server has stored on disk don't match, and that means corruption. So don't update the Sysmaster database. You can't use DB schema, you can't drop them, you can't do any of the normal features on it. You can run selects. Now, the isolation level is dirty read, and the data is very dynamic. A user may be running a query, and you can query the Sysmaster database and see their SQL and the query they're running, and then they log off or the query's over, and that information is gone. It's not saved. So you can do joins that don't quite make sense because the joining information is suddenly gone when you thought it was there. The data is only there when someone, particularly for users, is connected to the server. As soon as they disconnect, all their data in the control structures is gone. It's just like OnStat, and you can just like OnStat, you can run it at any time without worrying about locks. Same with running Sysmaster queries. Now, there's some undocumented tables, and there are many documented tables, and they've gotten very good at documenting them. And so my scripts have been tested on 11, 7, and 12. It has changed between earlier versions. So I do have earlier scripts that run all the way back to version 7 when I first started doing this talk. And many of them will still run even on version 12. But just be aware that every time you do a new release or an upgrade, one of the things that happens is the Sysmaster gets dropped and recreated. That's part of the upgrade process. And so if you put a table, you create a table out in the Sysmaster database, which you can do. When you do an upgrade, that table is going to be gone. Now, there's one or two exceptions to this not being real tables. One is a table called flags text, which is kind of interesting. It has descriptions about a number of the flags in the Sysmaster database. And just as a quick example, if I go in here to DB Access and connect up to the Sysmaster database and say select star from flags text, it tells me the table, this is the flag, and enters your number and what that means. Some of them make sense, some of them don't, but that's very helpful information. And a lot of the views in the Sysmaster database use this table to interpret the numbers of the flags. So let me sort of describe how I use this to do a health check. And we've got several levels of health checks we do. What I'm describing is sort of the basic, half day, let's do a quick health check and look at the values. And I will get on a server and have a script called Informix check.sh, and it goes out and it runs a bunch of OnStat commands, and it runs a bunch of Sysmaster queries. And depending on how busy the server is, it may take a minute or two to run. And voila, I unload the data. I find it much, my philosophy on using the Sysmaster database, it's better to unload the data and then take it to another server to analyze it. So while that's running, I'm going to show you the results of one I did earlier. I unload the data, and then I usually FTP it back into one of my other servers. And I get a series of output files, unload files, something like this. Some of them are on-stat commands. Some of them are straight out of the Sysmaster database. This is one showing me the DB spaces and what percent of free they are. One reason I like doing this is I can take that and load it into Excel. And here's that same data in Excel where I can make it nice and pretty and look at it and add notes and explain things to the client and say, this is what you're doing. So that's sort of the process I go through. Run a script, look at what's there, typically in Excel, and then analyze it and go through and figure out what it means. If you go to our website, all of these scripts, these are the scripts that there's about 50 scripts here. They're all there, and you can use them. I just put them together in a shell script and added the unload statements. You can use them individually, however you want to. There'll be a new link up there later this week, but the best way to go get them right now is to go to the presentations from the user conference, and right here you can go download the sample scripts. Come Monday, I'll have a new link up here though for this. So that's sort of the quick demo of what I do. And here are the script names that I use if you want to put something together like this. And here are the onstats I use if you want to put something together. And there's sort of the directory of what's in that zip file up on our website. So let's go through this and have some fun and talk about it. And one of the things that I can't script is what these mean, because every time I do this, I learn something new about Informix, about the server, about how people use it. No two sites are the same. And really the purpose of these scripts is to give some information to then analyze and try and understand what's going on. And I'm running a fairly busy system right now. This is one of our demo systems. It's got over 1,000 active user sessions right now. And I'm actually running about 5 different benchmarks all at the same time, just to make work. These servers only been up a day and 2 hours, and it's probably unrealistically write heavy. I'm doing a lot of writes in these benchmarks, but I thought that'd be fun. We'll go through, and I'm going to use this in the presentation to take a look at scripts and see, you guys can see how I interpret them. So the first set of tables I want to talk about are the server configuration tables. There's a table called sysmachine info that has basic information about your hardware and OS. This is a new table in version 11. If you're back on 10 or 9, it's not out there. There's license info and features, which is related to what you've licensed. If you ever have an Informix audit, these are 2 tables they look at. There's your on-config, and then there's a really important one called shared memory values, which is undocumented, but it's there, and you can go and see it. We'll talk about. And then that creates a bunch of server stats, and one of the key scripts I want to talk about in a little bit uses these 2 to do a bunch of ratios. Then we have a table with your memory segments and your buffer pool information, several tables on your CPUs, tables on your logs and your checkpoints and your IO history and your environment and your online log. So let's just dive in and take a look at this. One of the first ones I start off with is, what's the hardware I'm evaluating? And if you do a select star from sysmachine info, you get one record, and it will tell you the hardware you're running on. This was done on an Apple Mac. That's why it says the OS name is Darwin. And it tells me I have 8 processors. 8 were online. Tells me how much memory I have. I had about 16 gigs of memory on that box. How much memory was free? Let's take a look at this right now. And if I go to machine info here, I'm running it on this machine. This tells me I'm on a Linux machine. I've got 12 processors. 12 are online. I've got about 64 gigs of memory, and it's telling me I have 65 point something free, which is not quite right. It's the first time I've seen that big a number. Top gives me a more realistic number here. But this gives me some basic information about the hardware I'm running, so I can use to evaluate a server. The sys license information tells me not so much what's licensed, but what they're using. And it ties in with sys features, which is a view on sys license. And here's a query I run to take a look at what's being used. This is on an old server because the server that I'm running the benchmark on, I only installed last week, so there's not really a lot of information. But what happens is once a week, a record is put in this table, sys licenses. And you can see here, I picked this old system because it shows I upgraded back in week 10 of 2015 from 11.7 to 12.10. It tells you how many CPUs you've used, how many connections, and what's the max memory you've used along the way. Then there's your on config. This is really important for reading what your on config is. And there are 3 versions of the on config. There's the boot time values, the original. There's the effective, which is what's in effect right now. And then there are the defaults. And I like to look at the original and the effective to see what has changed since the server was last booted. Has somebody added on and it CPU VPs? Has AIO VPs been added? And if they have been, then should those be put in the on config so they're always there? And it sort of gives you, it's your on config in memory. I had a client erase their on config file, and they're in a panic. How do you get simple unload from this table to get their on config? Now, E tables that's undocumented. I tried to put an asterisk or undocumented, even though that's not always true, is this table called sys shared memory values. That has a bunch of information that's kind of important, particularly for ratios that I use. It has the boot time, and it has the time that the stats were last cleared. This would be the same as boot time, or it could be when you last did an onstat minus Z. And I use this a lot, you're going to see, to try and figure out ratios. Like if you're trying to figure out the buffer turnover ratio, or how many megabytes you're reading and writing per minute, this will tell you this is the time since that stat was last cleared, and so you can divide it by that. There's a lot of other good information in here, but I want to highlight this because a lot of the ratios I use are based on this parameter. Now, this parameter is Unix time. It's an int. It's not a date time. And so to make it useful, you have to use DB info to convert it to something that's useful. And here are 2 examples of using dbinfo to convert it into a useful time. I have a script that goes out there and gets the current time, uses dbinfo to convert the boot time and the time the stats were last reset. And then it gives me the interval, which is how long it's been since they're reset. And this is what I use for a lot of my ratios. Now, sysprof is another table that has general stats. Let me just show you this one because it's kind of interesting. Select star from sysprofile. You notice these names look like your onstat minus P, and they are. This is very similar to onstat minus P plus. I call it, it's like plus with a few extra things. And it has all the stats, and these are just counters. That's why they're an int 8, and they get incremented by the server as the day goes along. Every time a disk read happens, this counter gets incremented. Every time a buffer read happens, this counter gets incremented. And if you do an onstat minus Z, they're all reset back to 0 and cleared out. And that's why I need that time to tell how long it's been since you've done an onstat minus Z, so I know how long those stats are valuable for. And here's a partial list of what's in there, and there's a lot you can do with it. And like I said, it's very much like onstat minus P in terms of what you're looking at there. Now, I have a script called server ratios. Let's go out here and find it. Server ratios 2 is what it'll be called in your directory. And if I run it, it goes out there and says, okay, let's calculate some of these values. Like it gives me a read ahead ratio of 92%. I don't think that's so important nowadays. It tells me how many scans, and more interestingly is how many scans per hour has it been doing. It tells me how many sorts were in memory, how many sorts were to disk, and what's the max sort space I've needed. And a more interesting ratio is how many sorts per hour. I look at a lot of these hourly ones over time, and this is one of those things I like to set up if I can to run every hour and then capture that, and it will tell me some information. My buffer read per hour, my buffer write per hour, and the number of checkpoints per hour. And then lock request and what I call a lock wait ratio. How many times am I waiting for a lock compared to request? And then whether I'm doing foreground, LRU, or chunk writes. And on this server, I'm all doing chunk writes. So let's take a look at some of these numbers. Here's the script. So you can see this is done on the system that we're monitoring earlier today. These stats are hot off the press here. This server is doing a lot of scans. It's doing 1,087 scans per hour. Now, on a small table, that's not important. On a big table, that can be very important. And one of the scripts I'll show you later is how to tell what table is being scanned. Most of the sorts are being done in memory. That's a very good thing. So 7,606 of the total sorts when I looked at it earlier are done in memory. They're not going to disk, and that's what you want to see. Now, in this particular server, that's because I have a lot of memory set aside for PDQ priority, and that's why it's able to do most sorts in memory. Now, this is where it gets interesting, is looking at my I/O. Buff reads per hour. So that's buffers I'm on a 2K Linux server, so if I times that by 2, I'm reading about 1.4 terabytes an hour. I'm writing about 187 gigs per hour. These are numbers I like to look at and monitor when I'm monitoring a server long term. It tells me just basically how busy it is and how much data. And you got to remember, every time you write or read, that data has to come from disk. So this gives you an idea of how much performance you're going to get out of your disk. Now, this is a crazy one that showed up. Look at the number of checkpoints per hour. 19,000 checkpoints. That's 327 checkpoints a minute. If I saw that in a real health check, that would be my red flag. And that's why I do these. I'm looking for crazy numbers that stand out. That many checkpoints a minute, something is wrong. And if we come over here and do an onstat minus M just to look, you can see I'm doing checkpoints all over the time. Now that means a couple of things. Let's take a look at our checkpoint onstat minus GCKP. Most of my checkpoints are because of the logical logs. I'm filling up logs, and that's causing a checkpoint. So this tells me that on this server, my logical logs are too small. You can see that when you see, and sort of my key thing is when you get checkpoints greater than 1 every 5 minutes, something's wrong, and that's what I look for, red flags and things like this. And then you have to dive in and say, okay, what is wrong here? Why am I getting checkpoints so often? Well, I had a number of benchmarks running, and they're very write heavy, and my logs are too small. That's why I'm doing checkpoints. But you know, it may be a batch job that's doing a lot of writes. It may be a big load. Depending on your server, that's the next thing, is to drill out into what's doing all those writes that's causing all these checkpoints. But one thing that this does make clear is my logical logs are too small because I'm doing logical log checkpoints about every couple of seconds. I'm doing a whole bunch every minute. This is a busy system. My lock weight ratio is very high. You want to see this down in the 10 or 20 lock weights. Weight per lock. This is a huge number, and so that means I'm also having a lot of lock contention. With 1,000 users, we're running a OLTP benchmark. And they do get a lot of lock contention on this system. And that can be as simple as looking at your applications and how they do locking, to looking at your tables. One very common case for this is that you're using page level locking instead of row level locking. So that's another caveat I look for in these ratios. And then last is what kind of I/O am I doing? So Informix has 3 times it writes out. A chunk write is a checkpoint write, and all of my writes are at checkpoints, and that may be why my checkpoints are actually taking a bit of time. I have no LRU writes. LRU writes are what I call background writes that happen continually. My system, and this would be a very big red flag, especially if it's an OLTP system, is only doing chunk writes, which means every time it has to do a checkpoint, it's writing out data. And that tells me I need to look at the LRU queues and why they're not doing more LRU writes. If you ever see a foreground write, that's really bad news. That means that your system was not able to write the buffers out fast enough, and you had a lot of dirty buffers in memory. So that's sort of my ratio script. And let me just make sure the chat is working. Yeah, I see a couple of comments in the chat. That's good. When I'm full screen like that, I can't see the chat, so I wanted to drop out and just see where we're going. I started last night. This was about 150 slides, and I ended up cutting it down quite a bit. But I want to cover, so I'll cover some quickly and then spend some time on some of the more important ones. The one I just did on the ratios, I think, is one of the more important ones. Memory usage. There's a table called sys-seg list, much like onstat minus g seg, to show you your memory segments. And I put that together in a query that goes out there and translates the segment classes into their name, and then sums them up. And then it shows you the individual segments. So this is probably another key query I like and use much, called mem segments. And so this is telling me, okay, on the system, I have a message segment that's small, I have a resident segment, I have a buffer segment, and I have a virtual segment. Now, yesterday when I was testing this out, I actually had about 8 virtual segments. And that would tell me if your initial virtual segment fills up and it has to add another virtual segment, I was growing memory. In this case, I'm not, so it's pretty good. And then down here, it tells me how many blocks are being used of each one of these segments. There's another table called sysbuff pool that actually tells you by buffer pool. And this is really important now that you can have multiple buffer pools on a server. This tells you by buffer pool information about reads and writes and usage and time spent in the LRU queues and the number of checkpoint writes. So if you have a 2K buffer pool and a 16K buffer pool, this tells you by buffer pool. And Art Cagle has a ratio that I really like that he's graciously let me put into a script here called the buffer turnover ratio. And this is how often are your buffers turning over. That is, everything in memory is getting swapped out and replaced. That's a turnover. And your goal should be to keep it down to about 7 times an hour. This is, I think, one of the #1 performance improvements you can make in a system is to look at this. I was working with a client once, and they were turning over their buffers 300 times per hour. That's about every minute everything in memory was getting trashed out and replaced. So there's a lot of work that the system is doing in trashing things out. And oftentimes what would happen is somebody would want some data and then come back a minute later and the data would be gone from the buffers because it had been replaced by something else. So the goal is to keep it down to about 7 times per minute. Let's see what it's like on our system here. I ran this earlier and 71 times per hour. That's not good. I want it about 10 times less than that. This is when I ran it earlier. It was 79 times per hour. Again, your goal is to keep it down to about 7 times per hour. Now, what % of the I/O is from buffers? Onstat minus P will give you this as a total. This gives it to you by buffer pool. So if you have two buffer pools, and I only have one here, it breaks it down to your read percent and your write percent by buffer. Since I only have one, it's not as helpful as having two. Onstat minus P will give me the same information. Now, let's take a look at CPUs and the on inits and what they're doing. There's a table called sysvp list, which tells you all the on inits that are running. And some of the key things it tells you is how much Unix time they're taking. How many busy waits do they have to do? That means I call this make work, where it could actually use make work. And so it makes up work just to stay in memory. So how many things are in the ready queue waiting to run? That's threads ready to run on that on init. And a bunch of information about that on init here. Now, there's also a view called sysvp-prof that's a very simple view based on that table. And here's my very simple query to go out and see how much on init CPU usage you have. And I can run that here if I always takes me a minute to find the name. One of these, is it? VP-prof. Oh, it's the chat window's hiding it. Sorry about that. I had the chat window over this last column here, so I couldn't see it. VP-prof. So this tells me, okay, I've got 52 on inits running in this one server. Most of them, if I restart that, are AIO on inits, and this gives you an idea of how busy they are. Now, that's not good, particularly on this server, because I have 4 disks. So I have all these AIO on inits, and this is an example of how you can modify these scripts and use them. So I'm just going to add and text equal AIO. And let's just see if that limits it down to the AIO ones. It did. I've got 52 processes trying to write to 4 disks. Now they're fast disk, but that's a lot of processes trying to write to 4 disks. And that would give me a clue of maybe I've got some of my performance problem here is I've got too many things trying to write to the same disk. This is true whether you have a big SAN or a simple system with just a bunch of disks inside. A disk platter is like a spinning turntable and only so many things. And my sort of rule of thumb is about 8 processes can write to a disk at the same time. And so 40 is sort of the max I would want here for AIO. And I'd probably want less than 40 here. So that's another takeaway, to go tune the on config and set that up. This server I set up with auto tuning turned on, so it started those automatically. And I would probably, as a takeaway, go back and say, okay, let's turn off auto tune for the AIO VPs and manually set them to a better number. Also, if you look at them, I'll restart this. There are a couple that are really busy, but then after about this point, they aren't busy. Uh, they just can't get enough work there. Another indication that you have too many when you see this kind of curve where you've got some things that are very busy and then it drops off toward the end there. Now, threads. I put this under CPU instead of user, even though you could put this under user. There's a table called sysrstcb. That's the thread control block. And it's everything you want to know about what threads are running on your server right now. There's a lot of information about the threads and what they're doing. I'm just going to leave it for you to go look at. A simple select star from this table can tell you a lot sometimes. Another really good table is sysIO history. This has the last hour of IO history on your server. And this is one I actually, if I'm doing performance monitoring over a period of time, I like to go unload. If you unload it every hour, you've got some pretty good detailed IO information on your server. And this is one of those things where you may not need it right now, but a year or two from now, when you're getting that new SAN, this information becomes really important to then justify what the performance of the new SAN should be, what you expect, and what happens. I worked with a client once where I had 10 years of this data. And they started having performance problems, and the SAN guy said, oh, no, it's not the SAN. And I pulled this data out, and I said, okay, here's 10 years of waits. And all I did was look at the wait time. And you could see the wait time in the last couple of months had gone way up. I said, what's happened? We haven't changed anything. This is a OS SAN problem. Another table that is really, I think, kind of good is the sys checkpoint table. This is like onstat minus G CKP, gives you a picture of everything that's happened with your checkpoints. There's tables for syslogs. This is a script I had to use at a client site. They had logs all over the place. They had logs in every DB space there. And what was really bad was they had these very random performance problems. And I finally traced it to a log was being written in the same time that a DB space was being updated. And so we used this to track down all the logs that were mixed up with data and move those, drop those, move those out of the data and have a separate log DB space. To the checkpoints, the environment, and then you have online log. I like this one. And let me just, actually, I'm going to just do a new select star from sys online log. Oh, did I type it wrong? Gotta spell select right. And you can see this is like an onstat minus M. It's straight out of your online log. And one of the things I do in my performance health check is look at the last 1,000 records from this file. And that will give you an idea of the current state of your server and the online logs there. So that's the overall server. Now, the second area I like to look at is DB spaces and chunks. And before I dive in, let me, whoops, I didn't mean to do that. Let me just look at the chat. Yeah, I've already seen a couple questions. Hang on to questions. I'll get to them at the end because I'm only about halfway through the slides. Everything else in the chat, I guess you guys can hear me okay if I'm seeing questions. That's good. So, DB spaces and chunks. This is probably the second area that I like to dive into. And particularly what I'm looking for are which chunks have the most I/O and why do they have the most I/O. So there are a couple of scripts. There's one called DB space free. This is actually one of the first scripts I ever wrote using the Sysmaster database. And it takes a minute to run on this system because it's so busy. So let me run it right now, and I'll come back to it in just a minute. But it gives you in a very simple picture how much free space there is by DB space. And I was setting up a new system for a new client in Canada a couple months ago. And that was their one thing was, how do I know when I run out of space in the DB space? There are these big blobs. I can't do an LS to C or a DF to C. And this, I pulled this script out and said, this is what you run. Set it up in a cron job to run once a day. And you'll see how it runs. And here it is. So this is telling me I have 2 DB spaces that have no space free. And that's probably because I'm running these batch jobs that are just inserting records, and they'll probably fill them up. And then I've got all these other DB spaces with a bunch of space free. Chunk I/O gives you the I/O by chunk. Let's take a look at that. I have a summary one, and then I have a stat one that gives you basically the same information. And what you want to do is look at your reads and writes. It's the same information as onstat minus capital D, and except it's in a table and you can save it. And one of the things I do, this is probably a good time to mention this, is I do bring this up into Excel. And here's what I did earlier. I copied my earlier ones into Excel. And then in Excel, I can sit here and do all kinds of things like sorts. Go up here in Excel, do a sort. Let's, I have headers. Tell it I have headers. And let's sort by page reads from largest to smallest. And boy, that's a DB space that has had the most reads and the most writes. Let's take that and sort it by writes and see what happens. I did it in the wrong order. The batch DBS had the most writes. One of the things that's very important, and I always look at, is your temp DB space. And if you add a column over here, I kind of like to do this. This is one reason for bringing it into Excel. I'm going to call it total I/O. And what that column is just going to be the total of page writes plus page reads. This will give me what I call the busiest DB space here. And so data sales to DBS has had the most I/O here. Sales 1 data DB space has had the second most I/O here. So it gives you an idea of where your I/O is. Something to look at when you look at this is where the logs are and where the physical log is. The physical log is having a lot of I/O for writes on the system, and the logical log is. And then take a look at your temp space and see how that's doing. If you have a DB space that's overloaded, you want to spread that I/O out. So the table sysdb spaces is the same as the top part of onstat minus D. Syschunks is the bottom part of onstat minus D, and it has all this information out there. Syschunk IO gives you the stats by chunk. Now, a key question that comes up, especially when you want to do a reorg of your table, is where is free space? And there is a Sysmaster table. I call it it's how Informix internally keeps track of free space. This is the chunk free list. And it has the chunk number, the extent, and how much the length is how much free space there is there. So here's my script. I showed you this one. Where is my free space? This is the script, chunk free list. And it will go out there and show you where your free space is. So if you want to do a reorg, this tells you, okay, how much space do I have and where is it? And you can change the order by. I have this by DB space, chunk number, extent. You can actually change it to free pages and order it descending, and then you'll see where I have the most free space on top. IO by chunk gives me the IO, and I get a read and write percent. What percent of my IO is from that chunk? This is actually a really good one. Let me bring that one up. So it's telling me, okay, 41%, remember these are percents, of my reads are from this batch DB space. And again, just because it's SQL, you can change the order by on these scripts depending on what you're doing. What's on each chunk? Oftentimes you need to look and see where your table is and what chunk it's on. And this is a script I put together to go out and sort of dump what's on each chunk. And it's reading from a table called syspt next, which is where the partitions are, joining it to systables. And it's going to give you a map of what's on each chunk. I won't run that. Status of the chunk. Now, sometimes I will crop this down and just look at, is it inconsistent and is it offline? And in one sense, all you want to do is look for a yes here or a yes here and run that on a regular basis, and you have something to go out there and tell you if any of your chunks are in trouble, if they're inconsistent or if they're offline. So now let's move on to tables and databases. And I'm going to jump to there's one query I want to show you here that I've come up with in the last year that I really, really like. I've got a lot of others though, but we'll talk about them. So there's a table layout on disk, table extents, tables with sequential scans, and then table info 2016 is the one I want to spend some time on because I think that's the key one here. So sys databases is in sys tables. It tells you a little bit about every database that's out there. Sys table names has the names of all the databases. Sys extents has the DB space name, the table name, the address on disk, and the size of that extent, much like on check minus PE. SysPTProf gives you the IO by table. And SysTabInfo gives you some hidden information. It's got an asterisk by the name because it is undocumented and it may change. But it gives you a lot of hidden information about a table. Things like the row size, the number of columns, the number of indexes, the next serial value, the current serial value, the next extent size, number of pages used, and allocated. And guess what? You take the pages used and allocated, the difference is how many pages are free. And when those free pages are gone, the table's going to have to get a new extent. So quick query to go out and see what databases are on the server, and it gives you a list of all the databases on the server. This is one of my favorite queries to go out and say, what's the size of my database? I'm just adding up the total pages for a database. And if you have a database in different page sizes, this is going to give you an incorrect value. And you may want to change this to calculate it by DB space page size. What tables need reorganization? These are tables with extents. And here I'm going out and taking a look at the number of extents that a table has. How to calculate the new extent size. Now, this is a controversial one, and everything here in red you should change. This is going out and calculating your system size in KB, and if you're on a 4K page, you want to change that 2 to 4, and then put in a growth factor. And 1 is no growth. 1.1 would be 10% growth. 1.2 is 20% growth. And then we'll go out and sort of give you an estimated extent size for your tables. So here's an example of how you can use that. What tables have the most I/O? This goes out and reads SysPTProf and comes back and tells you what the I/O is by tables. What tables have sequential scans? Now, this is really important. Not so much what tables have sequential scans, but how many pages are scanned. If a table is small, it's going to get scanned. In fact, if a table fits in 1 or 2 pages, hopefully it will get scanned every time because it's faster to read it with a sequential scan than using an index when it fits on 1 or 2 pages. But if a table's big, and that's what this does, is take the size of the table and multiply it by the number of scans to give you how many pages are scanned. This is the key number you want to look at. And I'm going to show you this in more detail in just a minute. And so what's the table layout on disk? Gives me the start and end address for the table. Let me come back to index usage. Oh, next one's one. And then this tells me what my I/O is by index. Now, to really get an index, you have to join with systables in a database. So this joins with systables. And so you have to run this with each of your databases. And then it does an outer join to Sysmaster to get the stats, the I/O stats. And what I look for is if the buff reads and buff writes on an index are about equal, then that index is not very helpful. What you want to see is way more reads than writes. That tells you that that is a really helpful index. And that's basically what this is trying to do, is calculate which indexes are good. That means there are more reads than writes. 100 to 1 ratio is a very good index. 1,000 to 1 is a super index, and so on. Now, this is one script that I put together to get everything you want to know about all the tables. And all that data is there. I was working with a client, and I said, let me just put it all in one place. And it's trying to answer questions like, does the table fit on a page? How much free space is in that table? How big are the tables? How many tables have the most locks, most activity? All the information you want to know about it. And it takes data from 3 tables, systab name, systab info, and syspt performance, joins them together. And I know you can't read this. So go download the tab info 2011 and run it. And you notice I actually unload it. And what I do, this is one of those I unload and I bring it into Excel. And so this gives me an Excel database that I can sort all over the place. And let's look at total bytes scanned and largest to smallest. Boom, Bill's table. This had the most scans of anything. If I scroll over here, it's whoa, that is a huge number of scans. But this is the idea, is to put everything you want to know about tables into one spreadsheet. And then you can spend hours looking at this one spreadsheet. Let me show you another one that I like in this spreadsheet. Is I have a field here called does it fit, row fit. And this goes out and it's in the base query and calculates, is the row larger than the page size? And if it is, so these tables right here are candidates for being on a bigger page. That means that right now, and if you can sort of see that if you look at the row size column here, the row size, one row does not fit on a page. So to do a read, you're having to do 3 or 4 page reads. And if you had that row on a size that would fit, like putting these on 16K pages means you could get way more rows on a page, and your reads would be much more efficient than they are now. So that's one thing I use this for. This has all my I/O information. It has page free. This will tell me how many. Let me just show you how that works. Sort by, let's do page is free. I want the smallest value because that means it's going to run out of space. I've got some tables here. Whoa, look at that. So I've got 5 tables that are completely full. And the next time something gets inserted, they're going to create a new extent. So this is all the information about a table in one place, is what I call it. Now, the last section here, and I know I'm way over time, but I'm going to keep going, is your users. Now, this is the most dynamic part of the Sysmaster database because there's only data here when a user's connected. As soon as they disconnect, the data is gone. And it tells you information about their session, their their performance by user, locks, and wait times. Sys-sessions is a view looking at two underlying tables that gives you some information about all the sessions that are currently running and tells you if they're waiting on something. And to me, what's really important is critical. Is critical means that they're in the middle of doing an update. When a session's in a critical state, that means it's going to block a checkpoint. It's going to block something else from happening until it's finished its critical state. And so this gives you an overview of all the sessions on your server. And session profile gives you all the I/O, performance I/O for a server. Sess profile gives you buff reads, writes, sequential scans. And this is one. I tried at one time to join sys-sessions and sys-session profile. But again, because this data is so dynamic, I'd oftentimes get one table and then not find the corresponding table record in the other table because the user had logged off or the session had finished. Web servers that start and stop sessions really quick are very hard to capture with this. Syslocks is I think I told you this earlier, a 6-table join. There's a base table called syslock tab that doesn't have as much information as syslocks. This is about the only Sysmaster table I really tend to stay away from because it's so large. And it's much like onstat minus K. Syswaits tells you how long a session's been waiting. And you do have to have the wait stats turned on in your on config to have data in there. Otherwise, it'll be empty. So some examples. Somebody asked us on the CDI recently, how do you tell who's in a database? One of my first scripts, this and the DB space free were probably my first scripts, shows you who's logged on to a database. Same sort of thing, listing all the active connections to a server, monitoring usage by user, and this is an example I have in my script. All of these items, you can comment and uncomment them out as you need to do and review and do a health check. Now, what's the most expensive SQL running? This is my last query here, and one of my favorites. SQL trace is the best way to capture this data in real time, but it's a whole separate presentation. Mike and I did one a couple of years ago, and I was actually thinking maybe this is one we'll do again. But you have to turn on SQL trace, and there's a bit of overhead with that. There's another table out there that tells you a little bit called sys-sq explain, and I use this to capture a lot of data. It only looks at SQL that's running right now at this point in time, and it tells you what the optimizer assigned to it as the cost. So it tells you what the cost the optimizer gave to that query. Now, the cost may be wrong, it may be right. You don't know that. But this will tell you what the optimizer thinks is the most expensive query running right now. And I have a very simple way of running it. I like to run it, and if you run it like every hour and put it into a temp table or unload it, and then after you've run it for a while, collect the data and summarize it. This will give you the SQL statement, the cost, and how many times it's run. Now, you're not going to catch every little SQL statement if you only run it once an hour, but you will catch the big things. And if you run it for 24 hours or a month, you'll really catch the big things. And as an example, let me show you. And the output of this is really messy. I need to give you a heads up, depending on how your SQL. So this is, I ran this earlier on the system. This is what it identified as the most expensive query. And total estimated cost was, what's that, 30 billion? And it ran 14 times in about the 24 hours I monitored this. The second most expensive query, again, this is the query. Here's the cost, and here's how many times it ran. The third most expensive query only ran 3 times. This is what I look for, because this will tell me if I fix this one query and get the cost down, which means it should run faster, particularly for ones that have run a lot. I tend to go look at, if I'm monitoring this for a day, 10 times is probably a good number. For a month, maybe 100 times, 1,000 times. If I see a high cost item that's run, 10 times a day for a month, that'd be 300 times. It's worth spending some time trying to optimize that query. And so the goal of this is to identify SQL that you should optimize. And I want to end the query part of this with that. So this basically, we're using 2 fields from a view called SysExplain, which has a cost and the SQL statement. There are other fields here, but to me, I only want to look at those 2. And when I do this with clients, it's always fun because I'll put something up like this worksheet at the end, and you can, especially with the developers, and they'll go, oh, I know who wrote that, or yeah, but I've been trying for years to figure out how to write it better. That's the kind I like, because that's always a good challenge. This is the underlying table it's based on. Now, questions. Let me just do a couple things, and then I'll take questions. I want to do a couple of announcements, just because I know I'm very overlate, but I am going to come back to questions. We have 3 more webcasts planned. And Tom told me what his was going to be, and I've already forgotten. So, but it sounded really good. ER, best practices for getting started with Informix Enterprise Replication. That will be our December webcast. Is that right, Tom?
Getting started with ER.
Yeah, getting started with ER, best practices. Art's going to do one in November on schema. Mike's going to do his query performance tuning basics in October. This is really, I know this is October. I was so busy in September. This is my September webcast. I want to mention we have 2 courses coming up. Actually, we have a bunch of private courses coming up, so I can't talk about those. But 2 public courses, one in February, which is going to be the Advanced Performance Tuning class. And then in April, we're just announcing today, we're going to do an Informix for Database Administrators. I've had a fun. I just taught this course a couple of weeks ago, and it's most of the people who attend are Oracle DBAs who are moving to Informix, and I love it. It's a lot of fun working with them. And then the thing I'm most excited about is we're getting new servers. The first box came yesterday. That's it right here. I'm setting it up, installing Linux on it. But they will have 8 cores, and depending on what we finally configure, somewhere between 8 and 64 gigs. It should be 64 gigs of RAM. And they'll all have an SSD drive in them. You can sort of see that drive there on top. That's the SSD drive I've been experimenting with. So this is really going to be important for our performance tuning class that's coming up. Art and I are going to work on some new benchmarks and some new performance tuning things. And we need, for a big database, you want a server that, yeah, in real life it might take 10 hours, but you can't spend 10 hours in a class waiting for something to run. So we wanted something that would be fast enough to test some things out. And you know, every class, the first thing we do is take something that used to take 40 hours to run and get it down to a minute or two. That's the fun part of the performance tuning class. And this is what else we do. So let me go back to questions now and find your chat button. And first question I see is IO history table. It's not in 11.7. That's probably true. It was added fairly recently, and it may not be in the older versions of 11.7. You need to look at the last digits of your version, because I do think it was added. I'm running 1210 FC9 here. I think it was added in 11.7, one of the later FC versions. FC8, oh, that's fairly new. Interesting. So the comment was, so really good question. Does Sysmaster have info for ER? Yes, it does, and I've not covered it, I know. There is information out there for ER. The best place to go look, and this is, I forgot to mention this at the beginning, is in your Informix directory is a script called sysmaster.sql. And this is what I've used to learn everything really about the Sysmaster database. And scroll through here and look. And I'm always, every time I bring this up, I'm always finding new information. It does change with the version you're on. And so depending on your version, that may make a difference. Let me just do a quick search for ER. CDR. Yep, there's information there about ER. Good question. Yeah, you just, that was actually a really good question, because you just got me thinking about some new scripts I could do. Tom is doing a lot with ER right now, and that's why I'm really excited about his upcoming webcast in December. Any other questions? Yes, we do training on ER. That's the question, is do we do training on ER? I have a course, but it's only done privately. So if you have 4 people that would like to take it, let me know and we can do a course. I've done it for, you know, it's basically the cost of 4 people. And you don't have to have 4 people to do it. I've tried to schedule public ones, and we've never had anybody register for a public one. So I would love to do an ER training class, and I've done 3 or 4 privately in the last couple of years. So let me know if you're interested. Would love to talk to you about that. Any other questions in the chat? Well, if you think of something later, please feel free to send me your questions. And I know I went way over time. Thank you guys for hanging in there with me. This has been a lot of fun, and I appreciate your interest in this. And I look forward to seeing you at the next one on query tuning. I showed you how to find the queries that are the most expensive. Mike's going to tell you how to fix them. We'll see you at the next one then. Thank you all. Have a good day.